Today's demo stems from a real-world customer use case where customers are looking for a mechanism to perform security scans on external package dependencies before approving those external packages for use within their private environment. The particular use case that we're focused on today covers a data science workflow, although this pattern could be expanded upon to account for general developer workflows where they have external package dependencies. In our example, data scientists will pull the public package request CSV file from a private GitHub repository before appending a public package repository name and corresponding zip URL to that request file. They will then push their commits of that request file back to the private GitHub repository, which is configured with a webhook that is secured via a personal access token stored in AWS Secrets Manager. That webhook triggers the source action for AWS Code Pipeline, where Code Pipeline executes a build stage that performs a curl on the public package repository zip URL, ingesting that public package repository through centralized internet ingress through a NAT gateway that has an elastic IP attached, so we can use that static IP for the allow listing strategy for the demarcation zone between customer network and external networks. Once that public package repository is ingested as a zip file, it is persisted from the build stage as an output artifact, and then ingested as an input artifact into our security test and notify stage, where we are performing Amazon Code Guru security, informational, and security scans on that public package repository. Then, depending on the severity of our findings from Amazon Code Guru Security, if they are less than medium, we are publishing a new package version to our private internal package repository, AWS Code Artifact, or if those findings have severities greater than or equal to medium, we are choosing not to publish a new package version. In either case, notifying the requesting data scientist or developer via Amazon's Simple Notification Service, or SNS, that translates into an email that their public package has either not been InfoSec approved because the severity findings are greater than or equal to medium, or that they have a new private internal package that they can access via the Code Artifact private package repository. If data scientists fall into that latter group where their private package is now available, they can access that private package in their SageMaker Studio environment, which is a hosted Jupyter Lab environment. And we'll show you the workflow for downloading that private package asset locally. SageMaker Studio, being a hosted Jupyter Lab environment, looks like this, and we have a terminal open where I will show the contents of my current working directory. This is a local clone of this example private repository, where you see I have this public package request CSV file that contains these three public package repository names, LangChain, PyTorch, and NumPy, and their corresponding zip URLs. We'll just verify that that's the same contents of our local public package request file, as you can see, and then we will modify this public package request file to request access to XGBoost. So I'll add XGBoost as the public package repository name, and I'll navigate to the XGBoost public package repository and copy the zip URL. I'll go ahead and add that file along with a commit message before we push. The commit message will read add XGBoost. Then we will push our latest edits to our private GitHub repository. Moving over to the AWS Code Pipeline console, let me refresh for the code pipeline that was just deployed using our automation script. And you can see that we have that source action for the GitHub webhook that's enabled that triggers the code pipeline execution. Next, you see our download external repository build stage is in action, which you can see corresponds to the download repository build project on the right here. So we can see that this build project is currently in process. I'll open this up and show you the contents of this build project through the build logs. You will see in this build spec, we are effectively printing the directory before the external package repository zip file is ingested. We're doing some parsing of the public package request file so that we can get the external package name, get the external package URL as well, before we perform the curl on the external package repository zip URL, ultimately resulting in the addition of this new XGBoost zip file, which ultimately gets persisted as an output artifact from our build stage that will be ingested as we kick off the next security scan and notify stage that's executed via an additional code build project. That code build project, if we follow along on the right side of the screen, is shown here by this security scan code build project that we see is in progress. I'll navigate there and open up the build history along with these build logs. As we explore the build logs for the security scan and notify stage, you will see, again, we have the ingestion of some files from the previous build stage so that we can effectively execute the logic within our security scan and notify stage. We're doing some extraction of the file names again. We're even creating a unique file name. So you see this unique XGBoost file name. This is because if we deem that the public package is InfoSec approved, meaning that the severity findings are less than medium, we will go ahead and publish to AWS Code Artifact, and the asset name needs to be unique there, so that's why we have a unique random identifier for the XGBoost zip file. We're also calculating the SHA-256 hash value for that file in case we are to upload it as a new private package asset. And ultimately, we are using a CodeGuru security scan script here, a Python script, to implement the logic for uploading that public package repository asset, that zip file, to CodeGuru scanning, to CodeGuru security, so it can perform its informational and security scans. You see ultimately with XGBoost that Amazon CodeGuru security has medium or high severity findings found. And so an email has been sent to the requester with additional details. If we navigate to the Python file, you will see that we are instantiating some local variables based off of the environment variables that are persisted in our code build project. This allows us to get things like the unique package file name and the external package file name, as well as our code artifact domain and private repository name. We instantiate some Boto3 clients for CodeGuru security, code artifact, and SNS along with code build here. And then we create an upload URL so that we can invoke the CodeGuru security client create upload URL method, where we are uploading the zip file from the external package repository to CodeGuru security so that we can then perform security scans on that asset. Once we have that upload URL, we'll perform a put using the request library on that URL. Once the contents are uploaded to the CodeGuru security upload URL, we can then perform the scan using the CodeGuru security client here and the create scan method. Ultimately, we will go and retrieve those scan results and analyze them for their severity levels. We'll see down here, as the security scan is in progress, we will parse the dictionary that is a dictionary array here in JSON. And if the severity findings are low or not, or if the severity findings are greater than or equal to medium in this case, then we will notify the requester via email that Amazon CodeGuru security has found those medium or high severities. The SNS client then allows us to publish an email ultimately with the security scan name in Amazon CodeGuru security so that the triage can occur on the finding severities. If lower than medium severity findings are found, then we will publish the InfoSec validated package repository to the private internal code artifact, as you can see down here through the code artifact client publish package version method. If we navigate back here to the private package repository within code artifact, I will refresh this page, and we will see we still have no private packages available. I'll navigate back to our SageMaker environment, and I'll modify this public package request file, this time with a clean external package, one that will not have greater than or equal to medium severity findings. We will use an example clean package repository. and get that zip URL. Coming back to our public package request file, the public package repo name will be clean package, and we'll add that corresponding zip URL, and then go through the process of adding the file updates along with our commit message here of add clean package. We will push our updates to our private GitHub repository, then navigate back to Code Pipeline. We see Code Pipeline just invoked a new execution. And if we go back to our build projects, we'll see the download repo code build project is in progress. Once that completes, we will then invoke the security scan subsequent stage. While that processes, let's take a look at the logic behind Code Pipeline execution around the severities. So as you've seen, when a developer or data scientist performs their updates on the public package request CSV file and they push that to their private GitHub repository, that PAT secure webhook invokes the Code Pipeline execution. During the download external repository stage, we are downloading the public package repository via that zip URL, sharing that as an output artifact that can then be ingested as an input artifact to the subsequent security scan and notify stage, where we are performing CodeGuru security scans using that zip asset. We then get the findings. Once we get those findings, we are analyzing those findings to see what their severities are. If the severities are less than medium, we will publish a new package version to our private internal package repository in AWS Code Artifact. Or if those severity findings are greater than equal to medium, we will forego that step. In either case, we will use Amazon Simple Notification Service to notify the requester via email of either the severity findings and the corresponding CodeGuru security name, or we'll let them know that their new private package is available within AWS Code Artifact. As we navigate back to our code build console and move to the security scan build project, we'll see the results of when there is an InfoSec validated package. So this one is one that's actually been published to Code Artifact, and we can see the Code Artifact response here for the private package that was just published to Code Artifact, rather than us saying that medium to high severity findings have been found. So what does the email to the requesting data scientist look like when they receive notification that medium to high severity findings occurred through the Amazon CodeGuru security scan? This is the type of email they would see where it says, please refer to Amazon CodeGuru security scan XGBoost. So I can navigate back to my console and see the XGBoost security scan underneath CodeGuru security, and I can see the severity distribution with medium and high severity findings, along with the vulnerability assessment if I wanted to dig further into the CVEs that are generating the most findings. What about for the data scientist or developer whose public package request actually gets approved and published as a private internal package asset? They will receive a different email that looks similar to this, where you see InfoSec approved clean package. Please refer to Amazon Code Artifact private package clean package. As I navigate back to the AWS Code Artifact console and I refresh, you will see now I have a package name available underneath clean package. I will open this up and navigate to the latest version. Remember, each package version gets published with a unique file name, so I'll take the latest file name. Then I will navigate over to our SageMaker Studio environment. I will perform the AWS Code Artifact get package version asset command with the clean package with the unique identifier zip file specified as the asset parameter. That will allow me to download that asset into my local working directory. So when I list my directory contents, you will see that clean package zip file. I can unzip that file, change my working directory to the clean package main directory, and now I see the contents of my clean package repository, which was this clean package Python script, which is now available to me locally. This allows me to download the generic package assets from my AWS Code Artifact private internal package repository so I can access them locally. Alternatively, if these were something like PyPy or NuGet packages, I could use their respective package managers and install those using AWS Code Artifact CLI as well. But the intent here is to show you the ingestion and download of a package from your AWS Code Artifact private internal package repository after it's been InfoSec approved and validated. And that's it for today's demo. Thank you for watching.